Hi, this is Amy with Gerrie Electric, and in this IAB video, I'm going to create a small DLR network with a Compact Logix PLC and some distributed I/O and show you how easy it is to set up and configure this in IAB. So to get started, I'm going to create a new project, and I'm going to name this our network demo. And I'm going to start with the Compact Logix wizard because I know I'm going to be using a Compact Logix in this demonstration. So you can see here, this looks a bit different than the Project Design Assistant. You can choose the chassis supply voltage up at the top and include your spare I/O points. Now down here under the Network Creation Wizard, you can choose to create a network only if necessary to support your distributed I/O, or you can choose to create the Ethernet network regardless of the I/O you're going to be using. So I want to create the network anyway, and take a look at my options down here below. I can choose to use the Converged Plant-Wide Ethernet model or the Freeform model. The difference is the Converged Plant-Wide Ethernet model is going to conform to all of the rules for the Converged Plant-Wide Ethernet, whereas the Freeform model will let me place anything wherever I want, regardless of which cell or area it's going to be positioned in. I'm going to choose the Freeform model for this video so I can play around with the physical layout and not have to worry about following the rules that are consistent with the Converged Plant-Wide Ethernet model. Down here, you can see I have the option for my network and which kind of topology I'd like to use. I can choose star, linear, or ring. And as mentioned earlier in the video, I'm going to be creating a device level ring network. So you'll see what happens when I select new device level ring. You can see here that I lose the switches because using device level ring, I'm going to use the embedded switches that are part of the hardware. So as in the Project Design Assistant wizard, I need to enter my I/O points for the project. So I'm just going to quickly add 8 I/O points here. I'm going to click Next on the Analog and Motion tabs because I'm not planning on using Analog I/O or Motion in this demonstration. You can see from the Distributed I/O Network tab, I have the option of creating additional networks if needed. If I'm using a PLC, which has the option of adding on additional communication modules, this is where you would add them here. So I'm going to go ahead and click Next to my summary page. So you can see my subsystem, I have the option of naming it. I'm going to name it my Compact Logix. And you can see it selected me a processor based on my I/O count. Based on this as well, it's let me know what my remote chassis adapter is going to be to add on distributed hardware. I also have options down here to add on additional modules to this processor. You can see other options up here from the I/O wiring tab. If I'd like to use screw, push-in, or the pre-wired cable systems, these options are available for this series of processor. So as mentioned, I'm going to be using the 5380 processor as opposed to the 5370 in this demonstration. So I'm going to scroll down in my list until I find it. I can choose any of these modules here, so I'm going to go ahead with the smallest one, the 5069 L306ER. You can see my options have changed now. I've selected the 5069 processor. It tells me here the Compact Logix 5380 controller, 600 kilobytes of memory, 8 I/O, 16 Ethernet nodes, and standard DLR. I will be using this processor in DLR mode, but there is also an option to use it in dual IP mode. So the 2 gigabit onboard network interface cards can be split out so they each have a separate IP address, or they can be merged together and work as an embedded switch in the DLR architecture. Down here I have the option for my network adapter for my distributed I/O. It's going to be 5069 AENTR, and as well here I have my DC input and output cards. So I'm going to click Finish and let this system get built. The next pop-up that is generated is, would you like to add distributed I/O to be controlled by the processor that was just created, which I had named Compact Logix. If you choose yes, a distributed I/O subsystem will be automatically launched for you. So what that's going to do is launch this distributed I/O wizard here for me automatically if I choose yes. So I'm going to go ahead and do that. And you can see here all of the options available to me using the 5069 processor. I can use anything from the Armor Block I/O to the 5069 I/O down here. So because this controller is natively Ethernet, I have my Ethernet IP set up as my network type up here. And under this network generation area, you can see I have a few options. I can either create a new topology, which will add in this 1783 BMS 06 SL switch for me to create a new star topology, or I can integrate this I/O onto my device level ring. So under topology here, I'm going to drop down and bring it onto ring 001. That's the device level ring network that was created when I created my Compact Logix processor a moment ago. So I can go through the sections of this wizard and add a couple I/O points. You'll notice some changes here to the I/O series on the side of the wizard as I changed the number of I/Os in my fields here. What's happening is IAB is constantly assessing the I/O count that I enter to ensure that the options that it provides me for my distributed I/O platforms match what's available for the hardware, and it's checking all the compatibility as well. So I'd like to keep this all as 5069 compact I/O to go with the new series. I'm going to go ahead and add some analog I/O here as well. So you can see here, it's given me the 1769 compact I/O series with the 1769 AENTR and compatible modules to go with that. Now that's not the series that I intended to go with. I'd prefer to go with the 5069 option. So I can come up here to the family dropdown and see that I actually have 7 different series I can go with. IAB has checked for module availability and compatibility with all of these different series. The 5380 processor is backwards compatible, so I don't have to use the new compact I/O. I could use the 1769 compact I/O or point I/O or flex I/O for that matter. So I'm going to choose the 5069 compact I/O from here. So when I selected the 5069 compact I/O, you can see it's changed the part numbers for my adapter module, as well for all the analog and digital input and output modules I had selected as well. Down here, you can see I have the option of choosing additional specialty modules to go with my distributed I/O. The other change I'm going to make here is my chassis size. I don't need 31 modules on this processor. You can see down here I have 4 cards, so I'm going to change my chassis size to 4. Now I changed that chassis size of 4 to go with the modules I have currently selected. I can always go back into my hardware view and adjust that to grow or shrink as necessary in my application. So it gives me that pop-up again if I would like to add more distributed I/O to my network. I'm going to choose no because I'm pretty happy with what we have so far. So now I'm going to head on over to my hardware tab and take a look at what was chosen for me. I'm just going to expand this a little to remind everyone the hardware tab is this set of gears down here in the corner. So we can see I've got my Compact Logix processor and I've got my distributed I/O. You'll see both my PLC and my distributed I/O are both listed as 5069 chassis as they both use the same sliced I/O modules. You can see here's my PLC, my input and output cards, and my 5069 AENTR with its input and output cards. So as you're going through your project, and if you decide you need to add on additional I/O modules, you can go on up here to Configure Chassis and change the number of slots. This Configure Chassis button will merely show you empty slots where you can be placing modules. If you find those are no longer needed, you can resize it and they'll disappear. So let's head on over to our Network tab and take a look at the device level ring network that's been auto-built for us. So you can see here in my network window, let me just maximize this here for us. It's taken my Compact Logix processor and my distributed I/O and put them onto a ring architecture. What that means is one Ethernet port from my Compact Logix processor is going into a port on the AENTR, and the other AENTR port is going back into my Compact Logix. So with just 2 devices, you don't really see the benefits of DLR, or it's kind of hard to picture the ring architecture, so I'm going to create some more distributed I/O. I have the option of going back through my distributed I/O wizard and running it again. I also have the option of going down to my hardware tab and adding in new hardware, or I can replicate what I have here. So what I'm going to do is right click on my Compact I/O, and the option is right here to duplicate this. So I have the option to choose how many duplicate devices I'd like. I can go up to 10 units at a time, but as this Compact Logix processor is only capable of communicating with 8 Ethernet IP nodes, I'm going to add another 5 devices. Whoa, look at that. So even though this doesn't look like a device level ring or like a ring architecture because it's not really in a circle anymore, it is. Now you have the option of trying to follow these lines to figure out if it is still a ring, or have the option of tweaking this. So what I'm going to do is go on up to my connect mode. What you'll find in Integrated Architecture Builder is this connect mode might solve a lot of these funky wiring issues that you see. The software is doing the job correctly in integrating these 6 devices into the device level ring, but as you can imagine, the software is really not concerned about aesthetics the way we are. So if I go into my connect mode, you can see where each of these devices is connected together. I have the option of moving these connectors around to make it look like a nice ring. So if I just click and drag on these, you'll see that my wiring shifts, and this now looks like more of a ring architecture. I have the option to move the hardware around in this connect mode, and you can see regardless of its physical location, my PLC is still going to stay in this device level ring. I can also click on the ring itself and expand it. Again, these are all visual things. They're not going to change anything in terms of how the hardware performs or the bill of materials looks at the end of the project, but it is going to change the way we look at it as people. It's much easier to understand this ring architecture when it looks like a nice ring instead of a jumble of wires. So now you can see I have my 6 banks of distributed I/O, which can be edited individually from the hardware tab if I would like to add or remove I/O. It's a matter of simply clicking and deleting the modules, or dragging and dropping them onto here if I would like to alter them. So you can see all of these devices are connected through DLR using the embedded Ethernet ports within the hardware, but this doesn't allow any information to get out. All of the information is trapped within this DLR network. So I have the option of adding in a managed Ethernet switch that has DLR capable ports to get the information out or to communicate with another system. So my favorite way of choosing an Ethernet switch, as opposed to going through manuals or brochures or guides online, is this option here built right into Integrated Architecture Builder. It's all in capital letters, help me choose an Ethernet switch. So I can drag a switch onto this network, and what it's going to launch for me is a handy little guide. So I can choose that I would like to use a managed switch. Okay, it doesn't need to be a core distribution level switch because I'm down here at the machine. So when I choose my managed switch, I have a bunch of different options here at the top. These are filters that will remove switches from the below list that don't meet my criteria. So because this switch is being integrated into a DLR network, I need to choose that option here from my filter. So you can see when I click on Direct DLR, it removes the options below that don't suit. So for example, the lightly managed switch doesn't include DLR capability, so it's no longer an option for me. So what I can do now is choose the right size switch for my application. So if I have a rough idea of the copper or fiber ports needed, I can choose my switch from this list. So I'm going to choose a small Stratix 5400 for my application. So I have the option of turning these 8 small form factor pluggable ports into copper or fiber, depending on my needs. You can also see this switch is capable of SIP sync, MSTP, REP, Ether channel, flex links, quality of service, VLANs, as well as network address translation. So I'm going to click OK. And you can see this switch has been dropped into my network diagram. The one thing that hasn't been done though is connecting those ports. So to do that, I'm going to go back into connect mode and simply draw a line from my switch into my device level ring network. So you can see what that has done. That's added the 2 necessary Ethernet cables to integrate this switch into the device level ring. So now I have this network set up of a Compact Logix processor and 6 distributed I/O banks. They're resiliently networked together with a device level ring architecture, and they're connected to a managed switch, which can then bring this information external to the ring and elsewhere in my facility. So that's it for this video in the Integrated Architecture series. This was Amy Carter with Gerrie Electric.